Name that triangle. Name that triangle. 2, name that triangle.
RTS.
Why'd you pick RTS, Matt? You're correct. I'm not saying you're absolutely correct. Why'd you do RTS? Why didn't you pick anything with A, B, or C?
Oh, because they're not the endpoints at the sides.
We've been naming figures by their vertices this whole entire year, haven't we? Well, we run into a problem now. A circle has no vertices. So how do I put a name to a circle if it has no vertices? The answer, a circle will always be named by its center. We always name a circle by its center. So what would I call this circle? This would be circle C. All right, circle C. And as much as I hate it, there is an abbreviation for circle. God forbid we have to write out 6 letters, right? There is an abbreviation. Here you go. This is the same thing as saying this. Circle C. I know. But it's there for you. You might see it in your textbook. You can use it yourself, but that's the same thing as saying circle C. So we name a circle by its center because it has no vertices. All right, let's talk about different parts of a circle. You'll notice I left the actual words blank here. I just left the definitions. Let's first start with this line right here that goes through the center. This segment that goes through the center. Anybody know its name? I'm sure you've heard of it before, but this whole segment that has to go through the center. Anybody know what that's called? Really? Jonathan? Diameter, yeah. Diameter. Some of you guys kicking yourself because you thought that was the correct answer. Yep. Diameter. But it's got to go through the center. It's got to go through the center. Well, what if it doesn't go through the center? Take a look at my segment over here. What if it's still a segment on the circle, but it doesn't go through the center? I don't think you've heard of this one, so I'm just going to tell it to you right now. Anybody ever heard of a chord in a circle? A chord. Oh, shoot, I put it in the wrong one. Son of a gun. Sorry. Put it in the wrong one. That should be up here. Diameter passes through the center. One job. Start the video over. What about a segment where one endpoint is on the circle and the other one is the center? So it's not a diameter. It can't be called a chord, right? Can't call it a chord because this one is not on the circle. Avery?
Radius.
That is a radius, everyone. Center to circle is radius. Center to circle, radius. So I have a chord, which is just a segment on the circle, a diameter, which has to go through the center, and radius, which goes from center to circle. One last thing I didn't put on here, and I want to make sure we know the name of it because it's going to come up tomorrow. Anybody know what you call a piece of the circle here? Like this piece right here. It could be this piece right here. Any piece of the circle. Anybody know? A. What's it say later in the packet?
Arc.
Arc. Yes, this is called an arc of the circle. It's called an arc, a piece of the circle. How would you find the perimeter of triangle RST? What would you need to find the perimeter of triangle RST? Perimeter. 12? Perimeter. What's perimeter mean to you if I ask you to find the perimeter of this?
All the sides.
All sides added up. Darn it. I have a problem again, don't I? With the circle. What's the problem with the circle? There are no sides. So how can I find the perimeter of a circle? Well, I don't use the word perimeter anymore. This is today's topic. We're going to use the word circumference. That's the distance around the whole circle. All right, AKA the perimeter of the circle. All right, but circle doesn't have any sides, so I can't add them up. So we say circumference. And there's a formula for circumference. There's actually 2 of them. I'd appreciate it if you guys knew one of the other. Don't memorize both. That's too much info in this unit. One or the other. So the first one you can do, C for circumference equals, anybody seen that symbol before? What is it? Pi. It's the pi symbol. Look on your calculator right now. Make sure you know where it is because you're going to need it. Everybody see right above the division sign, there's the caret button. And then you have the pi sign right there. So most of you are probably going to have to say second caret to get it up, to get the pi button up. And remember, pi is just a number. It's not a variable, it's a number, right? It's a number, not a variable. So that's where your pi button is. And then you multiply pi times d. Any idea what I'm looking for d? What we just went over, Charlotte? That's the diameter length, yep. So the circumference of a circle can be found by taking pi times the diameter length. Or, if you prefer, you can use this one. Same formulas. 2 pi r now. So 2 times your pi value times r. R would stand for what? Radius, yep. And that makes sense because what is the relationship between radius and diameter? Diameter is twice the radius length. So, and then quickly, a little elementary schoolish. If you ever want a little saying to remember, if you can't memorize that on your own, coffee, pie, donuts. Coffee, pie, donuts. Use it if you want. Okay, use it if you want. Anybody ever remember the cherry pies are delicious? Apple pies are too. That's for area, but coffee, pie, donuts is how I roll. All right, you ready to find circumference of a couple circles? Very basic on the first one, then we'll increase in difficulty. So find the circumference of this circle. Here's what I want to point out to you. What am I looking for when I say leave your answer in terms of pi? Your final answer, when you circle it, box it in, should have pi next to it. Meaning, there's no reason to use the pi button here. I don't need it. I'm not rounding to the nearest tenth, the nearest whole number. Answer in terms of pi, your answer better be something pi at the end here. All right, so no need to press the button on the calculator. So let's do this. Get ready, numbers being called. Can we make a class decision anytime we do a circumference problem, what formula we're going to use? You can make your own personal decision, but as a class, can we make a decision? Anybody have a preference? Diameter, all right, that's what second period picked too. So circumference equals pi d. What's the 16 referring to? Name that segment right there. 2. Matt, what's that 16 referring to? Radius. But I need diameter, so what are you going to do with the 16? So I can plug it in. 10? Okay, thank you. 3? Multiply it by 2. So instead of plugging in 16, multiply it by 2, and I'm going to plug in 32. Now, technically, could you leave it like that? You could. How many of you write x7 and not 7x? Anybody write x7? I don't. So I kind of would appreciate it if you just changed the order there and wrote it as 32 pi. And then that answer is in terms of pi because there's pi in my answer. You guys all good here? I know that was nice and easy, very basic, but let's start challenging you a little bit. Go ahead, read through number 2. And if any questions come up you can think of, let me know right away. So I need the diameter and radius length here, if you know the circumference. C equals pi d, which we chose as a class. Where's the 106.4 going in for? Oh, 14. Where's no 14. 2, Matt, on fire again today. Where's the 106.4 going in? All right, plug it in, everyone. 106.4 equals pi times your diameter. I need to solve for d, diameter. So what are you suggesting I do on both sides to get the diameter alone? 14, yep, good talk. 14 again, great talk. Don't even think about it. 19. Divide both sides by pi. Now I can use the pi button on the calculator. I'll do it with you. Diameter equals, let's go to the calculator, 106.4 divided by pi. And I'm looking for what here? Nearest hundredth? Hundredth. Let's not argue over rounding directions again. So what am I looking at here? Nearest hundredth. 17, nearest hundredth. What are you saying? 33.87. Yep. Good work. And now I'm looking for the radius. So how can you figure out the radius if we know the diameter already? 17 again. Yeah, divide by 2. And probably you want to go back to make sure you're the most accurate and divide your original diameter. There you go. There's the word I was looking for. Diameter divided by 2. So divide by 2. There we go. What's my radius to the nearest hundredth now? Oh, 8. Good. 16.93. Only thing right now that's making me itchy here, because you're in honors. Anything here? Caitlin? Millimeters. Thank you. Units, if that problem has it. There you go. All good until we jump right to the honors level here now. Everyone all good? All right, let's jump right to the honors level now. We got a vocabulary word we have to review here. A square that's got a side length of 9 is inscribed. Where's the square then? On the outside of the circle or the inside if it's inscribed? Inside. Inscribed inside. So imagine a circle with a square inside right now. And it says it's circle J. What's that mean to me now after what we discussed at the very beginning of today's class? Circle J. What's J then? Oh, 13. What's J?
The name of the circle.
Okay, so it's needs more than middle here. J is the what of the circle? It is in the middle, but I got a better name for it. It is in the middle. Begins with a C, ends in enter.
Oh, circumcenter.
Just center.
Center?
Just center. Circle. I need an honors level one other than middle. So there's J. That's the center of the circle. Now okay. Whoa. You guys just told me where's the square again? Good enough? No? Okay. Better? It's inside. What's your problem? No. Inscribe means those 4 vertices have to be on the circle, touching the circle. So make sure your square when you make it, all 4 vertices are touching the circle. Oh my God, that's unbelievable. And the side is 9. All right, inscribed vertices touching the circle. All right. Find the exact same directions. I just wrote them differently. That's the same exact circumference in terms of pi. I don't want decimal. I don't want you to round it on your own. Just leave it in terms of pi when you see the word exact. So a lot going on in this problem. And we haven't even talked about how the heck am I going to solve it. All right, so you guys, we already know circumference pi d. How in the world am I going to get the diameter from here? Because everyone agrees 9's not my diameter. Absolutely not. That's not a diameter. Holy jeez. All right. Oh, boy. Don't do this on your paper. I'm just going to try some stuff out here. A diameter's got to go through the center, right? So here's a diameter. How am I going to find that? That's not 9, right? Anybody going to find that? Oh, well. All right. Well, I'm not going to do that. What about if I do this? Here's another diameter going through the center. Am I going to be able to find that length? I don't think so. Is there a diameter I can draw in that maybe I could actually find the length of? Because those two weren't going to cut it. Is there any way else I could draw on that diameter where you're like, ooh, I think I could maybe find that? What do we think here? Paul, are you kidding me? Let's go. Don't screw this up.
A diagonal.
A diagonal, correct. A diagonal of the square, correct. So watch, everyone. Yes, draw in a diagonal. Isn't the diagonal of the square also a diameter of the circle? Everyone see that? Well, Paul said maybe I could find it. Can you? Can you find the length of... What is that? What is that? All right, I'm done. I'm just going to freehand it. There you go. Can I find the length of that diagonal, aka the diameter? I hope so. Maybe. This is why this unit's so tough, I think. That's 9 because it's a square. Something we've been using all year long that could help me find that diagonal diameter. What do you got for me, Jonathan? Pythagorean Theorem. Whoa, 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 whoa! I'm still going to challenge you, young buck. Pythag can only be used in a right triangle. Argue with me.
This is a right triangle because a square has all of its angles are 90 degrees.
Darn right! That's right. You've learned something this year. That's why it's a right triangle. Squares have right angles. All right, here we go. Pythag. 9 squared plus 9 squared equals c squared. 81 plus 81 equals c squared. 162 equals c squared. Got to take what on both sides now? Square root both sides. Now, let me reenact what happened in my second period class. One of my students, great girl, great, unbelievable, shows me this on her calculator and goes, what do you want me to round to? And I had to ask her a follow-up question that said, what class are you in? What class are you in? Do you think I want this? Heck no. What do you think I want you to do with the radical? Simplest radical form. Thank you. All right. Why did I sign up for this course? Well, you guys that are struggling on your calculator right now to try to find the biggest perfect square, you already found it. You already found the biggest perfect square. Look at your work. What am I talking about? What is the biggest perfect square? 81, right up above, right? 81 times 2. So the length of the diameter, the diagonal is 9 radical 2. So here you go. Go back to the circumference formula. Circumference equals pi times 9 radical 2. I give you credit. Why not? I'd probably write a note on there that said self-respect. All right, if you left it like that, let's change it up there. 9 radical 2. Make sure the pi is clearly outside your radical. And what's the only thing I'm missing? Inches. There you go. Anything you want to ask there? Because I'm not done with the question, by the way. Oh, no. Oh, no, not in honors. I'm not done. Maybe another geometry class, but not here. All right, I need you to dig deep. Who gave me Pythag? Jonathan? You gave me Pythag, right? Fine. Good job. Give me another way I could have found that diameter not using Pythag and something we've used already this school year. Come on. Come on. Dig deep. Think you got it, Charlotte? Come on.
45.
Yes, there you go. Yes, these are congruent, so the angles across are congruent. 45, 45. Anybody remember the rule? What do you do with the leg to get to the hypotenuse? Multiply it by? Done. All right, so we could have done it that way. Good work. Good work. Any questions? All right. This is an intense unit if you haven't found out already. Oh, graphing question. Circle Q. What's Q then? Circle Q. What's Q then? 2. What's Q? Center. Graph it, everybody. 3, -2. There's Q, the center. And the circle goes through 7, 1. So goes through 7, 1. 1, 2, 3, 4, 5, 6, 7, 1. It goes through that point. What's the length of the diameter? Ooh. So if you want a visual of what's going on right now, because that's what I was told second period, that I had a couple of visual learners in there. Here you go. This is what it's saying. There's the center. There's the point on the circle. Boom, there's your circle. Look at that. Ah, wait till you guys get to do that. Huh? There's the circle. Find the length of the diameter. What's that right there? Q to that point. What is that right there? Name it. What did I just draw in? 3? What did I just draw in there? Eva? Radius. So if you knew that length, how could you find the diameter then? Let's finish this. 19. How could I, if I knew the radius length, how could you find the diameter? Double it. Multiply it by 2. Can you find the length of the radius? Every unit this comes up and you always, big sigh. How can you find the length of this radius here? I almost gave it away. 12. How can I find the length of the radius?
Distance formula.
Distance formula, yep. And now that I look at this, 20 through 24, I didn't even notice I left it at 19. Didn't even say anything over there, huh? Good karma. Hope it comes up like 3 times in a row now. Yes, distance formula. x2 minus x1 squared plus y2 minus y1 squared. All right, do your magic now. Do your magic. I'll ask somebody what you ended up for the distance of the radius. Sure about that over there, Superstar?
I was just testing that at 3.
What about that number underneath the radical? How'd you get that? 7 minus 3?
Well, what I did was...
Where's the 5 coming? -1, 5 coming from?
Okay, so I tried something different.
Okay.
Instead, I found the slope of this, and then I just did the slope down here, so I could find the other side, and then I found this point, and I did that point, and then I did the distance formula to find the diameter, and so I found to find the radius and multiply it by 2.
It's a good, I like it. Problem is, though, you don't know your x's from your y's.
Oh,
Watch.
did I do something
You
wrong?
did x minus y.
Okay.
It's going to work, Aiden. It's going to work. Good job. It's good, great thinking. But you just got to make sure y's to get subtracted and x's. So
Mhm.
do it that way now. See what I mean? See how you put a 7 and a 5 here? But
Yeah.
the 7's the x and the negative 5's the y. Yeah, you're fine. Good. How about this distance of the radius? 11. 5. Good job, Paul. So the radius is equal 5. So the diameter should be equal to 2 times that. 10. Okay, no units, so I don't need any there. Questions? That's on your own. Problem with that, Jonathan? Do some stuff on your own like a big boy, okay? It's tank top season. What are you doing with that sleeves today, huh? Isn't it tank top season? It's like almost 60 out today. No? Should be seeing you in flip flops, tank top. Sun's out, guns out. Right, fellas? We got Pythagorean Theorem here. No simplest radical form needed. Came out to be 10. Circumference equals pi d. So pi times 10. Have some self-respect. 10 pi. And I don't know if you guys fall into my category. I always look at the directions real quick and I don't see any units, but then you got to look at your diagram, right? 10 pi inches. 10 pi inches. All right, you're off to the races. Let's get started on this homework. Yes, going back to the textbook.
Megan, can you grab me one? You're working hard.